Hello guys, welcome back to my channel, and in last few days we were discussing about the cerebral cortex or the grey matter of the cerebrum. And we have studied the cerebral cortex from its superolateral surface, from its medial aspect, from its inferior surface. And now we have to go deep to the cerebral cortex. So deep to the cerebral cortex or the cerebral grey matter, you are able to see this white matter. And in the white matter there are certain fibers. Today you are going to see the three main types of the fibers present in the cerebral white matter. In short, they are the association fibers, commissural fibers, and the projection fibers. We will see each of those and some examples. And why do they appear white? We'll start with this question. They will appear white because of the accumulation of axons. We know axons have myelin sheath, so the accumulation of axons results in the white color of this area. And let's proceed to the chapter. So be with me. So now let's talk about the fibers of the cerebral white matter, and like I said before, there are three in number: association fibers, commissural fibers, and projection fibers. Association fibers, they are also known as intrahemispheric fibers. They interconnect the different regions of cerebral cortex within the same hemisphere, hence the name. And the commissural fibers, they are called the interhemispheric fibers, which means they interconnect the identical areas of two hemispheres, so they help in the interhemispheric transfer of information. And third one is the projection fiber, which connect the cerebral cortex with the other subcortical centers. First of all, let's see association fibers. And the association fibers can be broadly classified into two, as long association fibers and short association fiber. First of all, we'll see the short association fiber. They are also known as arcuate fibers or U fibers because they interconnect the adjacent gyri by hooking around the sulcus, hence the name the U fibers or arcuate fibers. And the long association fibers, they are arranged into 5 different bundles, and they are the uncinate fasciculus, the cingulum, the superior longitudinal bundle, inferior longitudinal bundle, and finally the fronto-occipital bundle. Let's discuss each of them. So let's talk about the types of association fibers, long association fibers, and the bundles are: first one is the uncinate fasciculus. It interconnects the motor speech area and the orbital cortex of the frontal lobe with the cortex of temporal pole by hooking around the stem of the lateral sulcus. Second one is the cingulum, or we can also call it as limbic association bundle, which connects the uncus with the paraterminal gyrus, and it almost forms a circle-like girdle, hence the name cingulum, because the word cingulum means girdle. And third one is the superior longitudinal bundle. It is the longest association bundle, and it interconnects the frontal lobe with the occipital lobe and temporal lobe. And the inferior longitudinal bundle, which interconnects the visual association area of the occipital lobe with the temporal lobe. Finally, we have the fronto-occipital bundle, which has the same course as that of the superior longitudinal bundle, which interconnects the frontal lobe with the occipital lobe and the temporal lobe, and it lies deep to the superior longitudinal bundle and is separated from it by the fibers of corona radiata. We know the fibers of corona radiata belong to the group of projection fibers, which we will see later. Now that we have completed the association fibers, it is time to see the projection fiber and the commissural fiber. Main commissural fiber in the brain is corpus callosum, which we have mentioned in the medial aspect of cerebrum, and the main projection fiber is the internal capsule. So the corpus callosum and the internal capsule, we will include these topics as a separate video, which we will upload soon. So let's move to the commissural fiber. The commissural fibers, they are interhemispheric fibers, so they should connect the identical areas of two hemispheres. And the main commissural fiber, like I said, is corpus callosum. Other commissures are the anterior commissure, posterior commissure, hippocampal commissure, and the habenular commissure. So the anterior commissure, they have two components: the posterior neocortical component and anterior paleocortical component. The posterior neocortical component connect temporal lobes of the two hemispheres, and the anterior neocortical component connect the olfactory regions of two hemispheres. Next, we will see the posterior commissure. It interconnects the superior colliculi, pretectal and interstitial nuclei of the two hemispheres. Next one is hippocampal commissure. It interconnects the crura of fornix and thus the hippocampal formations of two hemispheres. And finally, we have to see the habenular commissure, which interconnects the habenular nuclei of the two sides. And these are all about the commissures. So let's talk about the projection fibers. Like I said before, projection fibers connect the cerebral cortex to other centers of the CNS. And the most important projection fibers are the internal capsule and the fornix. The projection fibers are of two types, corticofugal fibers and corticopetal fibers. Corticofugal fibers, it starts from the cerebral cortex and it passes to the other centers of the CNS, whereas the corticopetal fibers, it starts from other centers of CNS and it reaches the cerebral cortex. And the main projection fibers of the neocortex include the internal capsule and the corona radiata, whereas the main projection fibers of the allocortex include the fimbria and the fornix. We have mentioned about the fornix while we are studying about the medial aspect of the cerebrum. Anyway, we will discuss about the projection fibers in more detail in the next video. So stay tuned. I'll be back, and till then, bye.